Okay, hi everyone. So the title of my talk is Modern Stack for All Books. So basically, I want to present you my work about building and engineering an online library for historical documents, mostly about Southeast of Asia, mostly about your little brother Laos. And I will be using deep tech and software programming and show you the method that we use to do that. But first, let's take a step back about why it's important to learn history and why history should be a pillar in modern society. Well, the first idea, clearly, is that it teaches us, it helps us understand the present and how it is shaped, how the countries are made, why the borders are like this, the population, the cities. But also, it builds identity and cultural awareness. What I mean by that, I have an example not later than yesterday morning. I was on a historical tour of Hanoi, and the guide explained us that because her ex-boyfriend was from Ho Chi Minh City, he didn't have the same way to interact with the family, with the community than her. It was less strong to them, and she believes it's coming from the two different historical paths that took North Vietnam and South Vietnam after the independence. And what is very incredible is that this woman, she studied history and used it to understand her own life and her own relationship. And I thought that was fascinating. Another thing is that it teaches empathy and humility. And for example, as a French person living in Laos that used to be a French colony, it's important for me to understand the history of it, of my ancestors, my colonial past, and to adapt to it and have some empathy. Now, history can help us navigate the modern world. And by the modern world, I mean this new era that we are in with AI and everything that we can call the post-truth era. This post-truth era means opinions and emotions matter more than facts now. Well, history doesn't agree with that. History will put facts above opinions and emotions. Also, history will train source criticism, and it's important to get trained over source criticism. I mean, having a look at a picture, having a look at a document, or any piece of content, and understand if it's deepfake, AI generated, human produced, real, wrong. This is central to history, this source criticism. But also, the topic of today is that history offers rich material for us programmers and tech people to work on. And that's what we will see today. The work I'm doing on the side is called GRAC LAI. I'm the president and founder of GRAC LAI, which is a non-profit association that aims at building a digital library of documents specifically focusing on the history of Laos. For the history of Vietnam, for example, there are amazing historians working a lot on it, and there are very interesting platforms. But you are the big brother, and we want to have our own platform to put on the map the history of Laos. I'm a software programmer based in Vientiane for already 10 years. So finally, the topic, it's what we call digital humanities. The definition of that, it's a field that uses digital tools and computational methods to study, analyze, preserve, and present human culture. Human culture could be literature, could be art, could be anything, and we will focus today mostly on history and a bit on ethnography. Basically, the goal of digital humanities is this famous image, which is finding the needle in the haystack. We want to find a piece of data among a large body of information. This large body of information, mostly archive documents, pictures, or anything like that. Here is an example of a program I developed at the time for the company L'Oreal, and we were putting thousands of images of Instagram beauty influencers on a grid. Then I reused this same software to put instead historical images, but the principle is the same. We give the user possibility to have a look at many documents, and they are actually looking for one specific. When you zoom in, maybe that's this picture that they are looking for. That's the idea behind digital humanities and behind the platform that we want to build. So mainly you can have in mind for the rest of this talk a little bit of this, which is a beta version, just focusing on pictures. So you can imagine you arrive on a website, and in this website you may have here the possibility to enter some keywords, and you want to see pictures related to those keywords later. It can be pictures, it can be text, it can be anything, but you are a researcher or you are just someone interested and you want to focus on one theme, and there are so many documents, you want to find the one right for you. So now let's have a look at some keywords for digital humanities. If you are a programmer, but even product owner, and if you work in finance or data analysis like we just saw before, those keywords will actually look very familiar to you. I'm talking about metadata, files, databases, algorithm, open source like the first talk, interoperability. We are definitely in the world of tech, even though I'm talking about history. Now, digital humanities is bringing some key concepts that are very nice to have in mind. The first one is called discoverability, which means the degree to which something, especially a piece of content or information, can be found among a large body of data. There is another concept that is very close. It's called findability. It means that you know the data is in the system. You want to locate it. You know it exists. How easy it is to be located when you are actually looking for it. So it's really related, those two concepts. Then there is accessibility. You are on your platform, you offer a lot of archival documents, but can you click on it, download, see the picture, or is it behind a paywall? Do you have a low resolution version of the picture? Do you have a high resolution version of the picture? All those things goes into the accessibility. And finally, I just learned this word. I didn't know much before being interested in those concepts. It's called serendipity, which means the unexpected discovery of something valuable while searching for something else. That's very nice for researchers. You are looking for a specific building, so you have a look at it in the database, and when you look at this building, you actually find the picture of another building, and you're like, oh, it's very interesting, and then you start to dig into this other one. It's by chance that you found it through what we call serendipity. So basically, we have to have this mental model in mind, is that for systems through digital humanities, mostly we have a lot of content here. This content can be text, image, video. We want to access, read, download the document. And this content has what we call next to it metadata. It will be information about the date, the author, or whatever. It's not the original content, but it helps us to find the content. And then to access all of that, we would have a user interface because we are still using design user experience, and we need to build the best one for researchers or people to access the content. Now, the topic of my talk today is to show you 3 specific methods that are using deep tech right now that we've used in GRAC LAI to build this platform. So first, I will be talking about handwritten OCR, which is basically how to extract structured text from paper, from handwritten paper, to make it searchable. What are the techniques to do that? Then I will talk a little bit about metadata, and mostly how to do automatic metadata generation using, for example, LLM. And finally, I want to focus on the whole infrastructure of the platform, the technological choices that we made to build GRAC LAI. So let's go for the handwritten OCR. Here you have an example of a letter that was written from some Navy person in 1891. So it's handwritten. It's very interesting to understand what is inside and maybe to make it searchable. So to do that, we will be using optical character recognition to transform it into full text. Maybe you've done that when you just take a picture of a printed document, and it's pretty easy now to get the full text. It's a bit more challenging when we are talking about handwritten, but as you will see, with the recent progress, it's now pretty good. So you have three ways to do that. I will go through the 3 ways. First one is to use specific online tools. And then the 3 ways we are going lower and lower, closer to the machine, more difficult. Second thing is to just use API access. And finally, directly plug it yourself to the model and do your OCR. So first, the online tools. You have big AI companies building models, and one of them, Mistral, let's say, it's a French one, and they've worked a lot on doing nice OCR model, and they created one. And then they allow you to use what they call their AI Studio, which is directly plugged with their model, where you can upload your file, and then you see here the result that is actually pretty good. So that's one way to just do your OCR. Then you get your text and you put it wherever you want. It's not a platform that has been really designed for researchers to do that. It's mostly designed for you to try their model on your document to see if it fits and if you can go further. Now, still in the online tools, we have Transcribus, which has been made specifically for historians. And this time, there is a lot of nice things. For example, you can batch upload. You can download multiple pages at a time. It's a bit, and you can try to switch from one model to the other, depending on the actual handwriting that you have. So it's a bit better, but it's still, when you are a developer using those online tools, it can be a little bit difficult to always upload and re-download. It's not easily reproducible. So now let's go one step further. We will be actually using API access, which means just having a small code to do the OCR. The idea behind that, you have your own computer here, you have your script on it, and then you are sending the PDF image to the API provider like Mistral, and they will be doing the compute, and they will send you back the raw text. Problem with that is a rate limit. You may have to send thousands and thousands of files, and they will tell you, no, you can only send 5 files per minute. And the token price, you will be paying a high amount of money. Maybe it's reasonable for your use case. Maybe you have many files, and you don't want to pay this high amount of money. So I will show you another option for that. But just basically, the result of the script is that I sent it to the API, and now I have in my own text file the result of the OCR. So now we can go even further. If you don't want to pay the rate limit and the token, we can actually go for direct model access. You don't want to send to the API, to the cloud provider somewhere in the US or anywhere. You want to have the model on your own computer. Then you will face 2 difficulties. The first difficulty is that actually it's not only one model that they are using. Maybe there is one model that will find the layout of your file. Maybe first they will be transforming images to PDF. There will be a lot of toolings around that. Files handling and processing. And then you actually need to have GPU to do it fast. Otherwise, on your computer, I don't think my computer is even able to load the model with the RAM that it has. So we have those 2 problems. Let's see how we can fix them pretty easily. First, the tooling. You have some open source solutions that gives you the possibility to do all of that out of the box. I like to use one called Marker, and I just copy-pasted what it's providing from GitHub, so you see the kind of things that it's doing out of the box. It's converting PDF or whatever, PPTX, DocX. You don't have to care much about the format of your document. You just send it to them. It will format the table, extract the images, remove the footer and the header, give you back data either in JSON or whatever. So there is a lot of nice feature that you get out of the box by using this open source solution called Marker. Now, what about the GPU? Well, I like to use this service called HyperStack. I believe they're German, and they allow you to just rent a virtual machine with some GPU for a price per hour. So I go for the 50 cents per hour here, and then you get your machine, and the idea is you connect to it, you do your thing as fast as possible, and then you kill the machine, and hopefully you didn't spend too much money out of it. So there the idea is you move the computation part from your computer to their own VPS that you booked for 25 minutes, 1 hour, 2 hours. And then you download the result. Here are just the line of codes that I'm using to do that. You don't really have to look at it fully, but I just want to show you the steps, how easy it is. Here, the clock starts. I want to go fast because I don't want to pay a lot of money. Then I'm connecting to my new virtual machine, installing Marker that I told you previously, then copying using SCP or rsync, copying all my file to this new virtual machine, running the OCR. Maybe it will take 10 minutes, 20 minutes, 25 minutes. I download back the output, and I kill my instance. Task finished, output downloaded, hopefully not too much money spent. So that was about handwritten OCR, and it works surprisingly well now. And we can move on to the second method that I wanted to show you. Previously, we were focusing on text. Now we will be focusing on images. Let's say I have thousands of images, and I want to be able to filter, search, whatever about it. So the idea is to attach to the picture some structured metadata. I would have, for example, here, I want to have the location, the date, some keywords about my picture. I don't want to do it myself, so we can use LLM to do that. So large language models do not work on images, they work on text. Luckily for me, on this batch of pictures that I had, there was the title of the file that provide me some information, but it's unstructured data. So I do have to ask the LLM to transform this, which tells me the district, the province, the date, into structured metadata. Now for another collection of images that I got, we had a full description, and it allowed us to extract, let's say, the ethnic group for this specific picture from the description. Now you may be saying that I'm a little bit cheating, using work that has been done manually by human to get the actual text. That's true. Sometimes you're lucky to already have some information. However, you can also plug directly the image to the language model using what we call VLM, Visual Language Model. And actually now, in all of them, Mistral, ChatGPT, you are actually often interacting with a visual language model, which will first look at the image that you upload and then generate some text out of it. For this specific image, I cannot really ask the model to give me the ethnic group for sure. It's a bit too complicated. but at least I can have some interesting keywords that would describe my image. Finally, I want to discuss a little bit the platform and how we decided to build the website to access all those documents. So first, let's have a look at the access of all those images. There are some interesting things as well. Yes, I want to talk about accessibility and accessing images easily. So those comments that I'm making, you could be also using them in your startup about whatever images, even if it's user-generated images. Those are same principles, because the idea of this talk is to show you how digital humanities is actually using the tools of normal software programmers. So we want to have multi-size display, we want to have appropriate format to store our images, and we want to have fast access to it. So how do we do that? Well, first we will process the images. Here I got, let's say, 2,000 images like this, so I pick up one and I show you what is happening to this picture coming from an architecture dataset. That's the name of my image, Modernist House 1965.jpg. And what I want to do first is to actually give it just to normalize the name. I want to have a unique ID for the name. So for this, I will just be using Node.js to rename all my pictures to have this unique ID so I can read of this complicated and non-standard file name. Then out of that, I want to change the format. I don't know if you've been using WebP format, but it's been developed by Google for the last 15 years, and it's very optimized and allow to have very fast loading and high resolution images for a small size. So to do this transformation, it's only one line of code. This time I'm using bash code with the ImageMagick software from Linux. Then also I want to have big size images and thumbnails images depending on where I am on my system. So for that, using ImageMagick as well. And now I have two versions of my image with two different sizes. Now, we continue the process talking about the platform architecture. Where do I actually store my pictures? Where I actually store the images so they can be easily accessible by every user around the world? Well, the answer here, it's two things. It's S3 bucket and CDN, Content Delivery Network. Same, to do that, I'm just using a one line of code that will be uploading the file in the right place. Let me just tell you what are those two things, S3 and CDN. So S3 buckets, it's kind of a nice way to store your data outside of a file system. So what is good is that it's growing. If you add more data, you can have more space. It's not like you have to pre-buy a certain number of gigabytes. And you have very easy access from the web and a nice web interface to look at the objects that we call that you uploaded. So S3 is actually a standard developed by AWS, but you can be using Cloudflare or OVH or many providers that give you this very nice interface for your images. Now I mentioned CDN as well. It's a content delivery network, which means when a user from Vietnam is accessing the data, I want to provide the data from a data center close to him. If I didn't have a CDN, maybe my data center is in France, and then the latency would be big. While with a CDN, they will be copying the data everywhere around the world, allowing fast access and low, what we call latency. Final point, I want to discuss about the search. And so I mentioned about how to store the pictures. Now, how to actually do the search. I will just mention the tool that we used. I'm using a tool called MailiSearch. It allows you to just send HTTP request with a nice query language, and then it's typo tolerant. So if your user is saying Yao or Yao with an accent, it will still be able to give you back the list of images that it wants. So we are using this open source system, MachineLearning, for handling the user request. There is a little bit of complexity in the fact that our metadata is actually stored somewhere in a SQL database. And then every time there is modification, then we do what we call rebuilding the index for MachineLearning. So MachineLearning is not our source of truth. That's not where metadata is edited or inserted or ingested. This would be in a previous database, but then every change there would be materialized downstream in our search index, MachineLearning. Finally, let's have a look at the architecture for this small thing that I showed you. So the front end maybe is not that great yet, but at least the rest of the infrastructure is in place. So the user would start to access, wants to access through the front end. Actually, it's being cached by Cloudflare. And then every time the user types a keyword, it will query MachineLearning. MachineLearning will then give back the ID of the images to display, and this will be loaded from the S3 bucket, also cached by Cloudflare in the CDN. And then the developer is here. The developer would be on its own computer running some bash script that we saw previously from the raw images, maybe interacting with the API, LLM API, to get some more metadata, and then ingesting it in our source of truth, which is SQL database. All right, I'm at the end of this presentation, and as you could see, we've been through a lot of very interesting topics. We talked about LLM and VLM, structured data, unstructured data, very interesting image processing methods, a lot of infrastructure work, web development, and even I didn't touch really the design and user experience part. So that's a lot of things for you to learn through just history. If you want to learn all those things, you don't have to work in finance, you don't have to work in marketing. You can just go with us, come with us, and work on historical documents. So if you're interested in doing this kind of work, either for our own document or for Vietnam, please do get in touch. I would be happy to exchange with you. Thank you.